Good afternoon, everyone, and thanks again for joining us at Static Analysis Day hosted by Verifysoft, and thanks for inviting me to speak with you today about DevSecOps and detecting zero-day and end-day vulnerabilities every day. So just a quick introduction about myself. My name is Walter Capitani. I'm the Director of Product Management here at GrammaTech. GrammaTech is a company that has been producing code analysis tools for over 30 years, particularly our static code analysis tool, CodeSonar, and our binary software composition analysis tool, CodeSentry, along with many, many research projects in the areas of code analysis for both source and binaries. So today I'm going to be talking to you about the idea of DevSecOps and how we can detect zero-day and end-day vulnerabilities as we're doing our development. So when we talk about software development, a lot of the time we talk about the idea that you can have things good, cheap, or fast, but you can only pick two. And in software development, a lot of the time we're talking about trade-offs between speed of development, the security of our software, and the quality of our software. And that sometimes in order to get fast development, we have to compromise maybe on security and quality. And then when we start to put an emphasis on security and quality, it slows us down and we start seeing our release dates slip, and we're not sure of our timelines because these processes, security and quality processes, have detected issues in the software that we need to correct. And sometimes we just don't have the ability to do all three of these the way we want. But I like to ask, why not all three? Why can't we have all three? Have fast development of our software, quick iterations, quick releases to customers with a high degree of quality and a high degree of security. And to do that, we like to talk about a concept called DevOps and DevSecOps working together to help achieve this goal. So the DevOps movement was the idea of integrating testing into every code change. So what we're doing there is, instead of running our code, developing our code, and then at the end of a development cycle, whether it was a month or 2 months or 3 months, let's say, running a QA process where we then find out all the bugs that are present in our code, and then we have to fix them. So that results in a big list of bugs and a very indeterminate time frame of when we can get this software released. So the idea with the DevOps movement is to integrate this test phase into every code change. So we're talking about unit tests, functional tests, and deployment tests, such that we know after every code change if our software is functional or not functional, and to what degree, and we know what issues we have with it. Right? And because those issues were detected between the last code change and the current code change, we never are too far away from working code. We could always just go back to the previous version the day before, and we can have a working piece of code again. So it means that we never get too far down the path of changing our code and have issues, unresolved issues in it. So when we look at security in the context of DevOps, security traditionally has been viewed as a post-development or kind of a quality assurance task, right? So something that was done after we developed our code. And so we're working away, maybe we've got DevOps implemented, so we're doing an agile development and we're fixing bugs as we go along, but nobody's really keeping track of the state of security of the product until we say, hey, we've got a release candidate, right? And then the problem is you scan your release candidate and you find out you have 10 libraries that have vulnerabilities. You find out that you have some zero-day tainted data things in your code, and now you have a big list of things to fix. And your customers are demanding security, the end users are demanding security, and you have vulnerabilities, and now your release date is starting to slip. So the idea behind the DevSecOps movements is we add security to the development phase and the testing phase of our software development lifecycle, and we bring that security testing into our day-to-day verifications. So this allows us to find and fix our security vulnerabilities earlier, much, much earlier, as they're introduced into the code, and it reduces the uncertainty about how secure the software is. We can get a report every day now that tells us how many existing vulnerabilities we have, how many new vulnerabilities we have, and how long it will take to resolve them. Well, now we know we only have a very short list. So if we decide we want to release tomorrow, we know we only have 1 or 2 new vulnerabilities to resolve, and we can move on. Okay, so that's the idea of DevSecOps, building on this DevOps movement. So when we talk about vulnerabilities, what kind of vulnerabilities are we looking for? So we generally hear people refer to zero-day and end-day vulnerabilities. So zero-day vulnerabilities, those are ones that have just been discovered in the code, and they can be exploited today, right? There's typically no patch available because they were just discovered. But on the same token, because they've just been discovered, they're not well known, and so exploits for these may not be very widespread. And for example, the zero-day initiative is currently tracking over 400 undisclosed vulnerabilities discovered in 2021. So these have been reported to the zero-day initiative, but not yet disclosed by their manufacturer. The other kind of vulnerabilities we're looking for are end-day vulnerabilities. So these are ones that can be exploited right now as well, just like a zero-day vulnerability, except they've been out for a number of days. They've been known for a long time. So typically there is a patch available from the vendor. However, exploits are very likely to be widespread. So for example, a 2020 study of 60 vulnerabilities showed that 30% of them were exploited more than 1 week after the patch was issued. So what that means is that the vulnerability was exposed, it was reported in the media, it was disclosed by the manufacturer, usually at the same time that a patch is made available. But 1 week after that patch is made available, people are still being exploited, the users or the systems are being exploited because now the exploit's available in the wild and people haven't patched their software. So this is the big risk that comes along with end-day vulnerabilities. So where can you find these zero-day and end-day vulnerabilities? Well, you can find them in source code, for example. So you can, if you have the source code available to you for the software product you're developing, you can discover them there. But they can also be found in open source code. So you may have this source code available to you, but you're not as expert. For example, your developers don't know that code inside out. So they may not know how to find the vulnerabilities in there. They may not even look at that code, but there may be some in there. And then finally, you can find them in third-party source code and binaries that you may be bringing in from a vendor or a partner. So the challenges with source code vulnerabilities is that they can be expensive to fix. When you find vulnerabilities in your own source code, your developers are typically experts at that code. They know how it goes together, so it can be relatively cost-effective to fix them. But if you find a source code vulnerability in open source code, now you have to decide if you're going to take on changing and modifying and patching open source code that you maybe don't know so well. So this may become a much bigger effort. You may introduce bugs as part of your fixes. And the whole point of using open source code is to increase your speed of your time to market or reduce your time to market, pardon me. And so if you start fixing open source code, you're really losing that benefit. And obviously third-party commercial components, even if you could find an issue in their source code, again, it's the same problem. You don't know the code. You may not have the right to change it or the ability to change it and fix it. The other challenge, of course, is if we find vulnerabilities in binaries, there's typically no source code available. So finding the vulnerabilities can be more difficult, and fixing them generally requires upgrading your binary package to a new version, for example, or getting something new from the vendor. So in order to detect both these kind of vulnerabilities, we need to implement a comprehensive security strategy as part of our DevSecOps approach. So for internal source code, you need to eliminate vulnerabilities by eliminating them directly in the source code. Your team knows the code base, so therefore this should be relatively cost effective, and ultimately it's your own code, so you want to take those vulnerabilities out of there. And if you use a DevSecOps approach where you're checking your code every day for these security vulnerabilities, then you can quickly find them, and the cost of remediation is lower. When you talk about binary code then that you're receiving, you want to eliminate both zero-day and end-day vulnerabilities, because a lot of binary code may have, or open source packages may have, already disclosed vulnerabilities. And the typical remediation there is through package or binary or vendor updates. So we're not modifying source code, we're replacing the binary and upgrading the binary. So now we're going to move on to our first poll question. If you look on the stage, there is a poll. Click on next to the chat link, there's a poll question. So if we could take a few seconds here, and the question is, what kind of security vulnerabilities are you testing for today? So are you testing for none, 0-day only, end-day only, or 0-day and end-day vulnerabilities? So I think just to the right of the chat screen. So we're going to wait a few seconds here for this to come in. There you go. Keep it going. So what we found in our discussions with a lot of our CodeSonar customers is the challenge of binary analysis continues to pose them problems, in that they are able to verify their own code with some tools like CodeSonar, for example, but they are struggling to find a way to ensure that the content, open source content of their projects is secure, as well as binaries from vendors if they are secure as well. All right, well, looks like we have the responses. So overwhelmingly, the answer is none, and testing for none of vulnerabilities today. So hopefully you'll find this talk informative. We've got a few testing for 0-day and end-day, and some testing for both. So that's great. We've got some folks leading the way here on the security front. Great, thanks for answering. All right, so let's dive into DevSecOps for source code. So GrammaTech, as I mentioned earlier, has been involved in static application security testing for a long time with its CodeSonar platform. And for those of you that aren't familiar with CodeSonar, it is a multi-language static analysis tool with abstract execution technology. We've got support for the most popular programming languages and hardware platforms. And what CodeSonar provides is not just warning or defect finding, but it provides a full management interface so you can actually suppress warnings and manage them in a process-driven way with our CodeSonar hub. We've got a friendly interface for developers where we don't just report a warning on a line, but rather we give clear explanations and path information of how a defect actually comes to pass, what conditions, if statements have to be true or false, and we provide visualization tools for the entire program to make it easier to track down those bugs and what other code they might be affecting. The tool can be integrated with popular CI and CD tools such as GitLab and Jenkins. So obviously that's our focus here today on DevSecOps, is integrating static application security testing into your CI/CD workflow. And of course, CodeSonar can identify many of your common security vulnerabilities. So these would be 0-day vulnerabilities in your own static code, in your own source code, pardon me, that such as tainted injection or buffer overflow or command line injection, those kind of very severe security vulnerabilities. So when we talk about DevSecOps for source code, again, referring back to our earlier diagram, we're talking about integrating a static application security testing tool into your development and test cycle, so that every time you make a code change and you run it through your CI/CD pipeline, you've got analysis taking place and new security vulnerabilities are being reported. So here's an example with GitLab. So this is a typical GitLab workflow. We've got on the left a developer who creates a new branch, is pushing code changes into that branch, and then you've got this continuous integration box where the automated build and test is happening. And this is where our CodeSonar workflow is into this automated build and test cycle. So we're going to zoom in here and see that in the CI workflow, you'll integrate a CodeSonar runner as part of your GitLab pipeline merge request. So every time you try to merge code, we're going to run whatever tests you're running, as well as a selection of static application security testing tests via CodeSonar to reveal any security vulnerabilities. So what this achieves is a shift left from that quality assurance aspect of static code analysis and testing into the development phase. And this is going to help us detect our zero-day vulnerabilities every day in our development flow. So if we take a look here, these are screenshots from the GitLab integration. So on the left, you'll see CodeSonar will provide a summary of what kind of warning classes have been detected. So each of these classes corresponds to security vulnerabilities, along with a summary of the high, medium, and low vulnerabilities that you have in the top left. Then in the middle screen here, we're showing a vulnerability report. So this is GitLab's integrated vulnerability report, which is presenting the data from CodeSonar. You've got the classification of vulnerabilities, along with a detailed list of the detected vulnerabilities. You can work with these directly inside of GitLab. So developers don't have to leave the GitLab interface if they don't need to. They can just view a defect. You can see here detailed information from CodeSonar is being provided on a specific issue, such as this resource leak. And you've got everything you need to triage a defect, go back to your source code, take a look at it, and then you can decide who to assign it to. You can create a GitLab task directly from the GitLab interface to assign this to a developer. So typically this might be a peer review or a security reviewer who would be doing this work. And you can see at the bottom here, if you want to dismiss the vulnerability or create an issue, that's how you can do it. So it's right inside of GitLab. But as I mentioned earlier, CodeSonar does provide some extremely detailed defect information, which if you're having trouble, for example, understanding what conditions you might need to reproduce this defect or understand under what conditions it might occur, you can just click in GitLab on the issue screen and it will bring you into the CodeSonar hub, which will provide the full warning class information on a vulnerability. So you can see in the top half, you've got the summary of the warning along with all of the mappings to the various CWE identifiers and CERT-C identifiers. And then in the bottom half, it's got the control flow information indicating if an if statement needs to be true or false, for example, in order for this warning to occur. So you've got the full power and full information of CodeSonar, but you've also got the workflow of GitLab, which is how your developers are going to be used to working. So CodeSonar also offers its own built-in reports in the event that you want to use these, for example, from a management perspective. So every week you might present these at a weekly meeting to understand if you're introducing more defects into the code or if they're being reduced. And also you might use these for artifacts, for example, if you're doing any kind of compliance activity in the medical device space, for example, or automotive space, where you want to prove that your code not only is of high quality, but also very secure. You can use these artifacts to show that you have no defects of a certain kind present in your code. So the summary of the DevSecOps for source code here is that we're moving the security of source code into the development cycle. Early detection of these vulnerabilities reduces the cost of remediation, the risk of missed release dates, and that security is not just a quality assurance activity, but it's an everyday activity. All right. So now we're going to jump in to the idea of DevSecOps for binaries. And like I mentioned earlier, this is something that a lot of people that we're talking to are struggling with how they can achieve this and secure that large amount of third-party code that they have in their software products. So the tool we're introducing here is a CodeSentry binary software composition analysis tool. It identifies open source software and third-party components with known vulnerabilities. And as we mentioned earlier, the known vulnerabilities or end-day vulnerabilities are a major threat to deployed software. So CodeSentry is going to continuously identify these end-day vulnerabilities in your software. The tool will create a software bill of materials, or SBOM, which is increasingly being required by compliance and governance agencies to prove that a vendor knows what software is in their code. Customers are also requiring this kind of thing very frequently now because they have their own obligations to their customers to deliver secure platforms. And finally, CodeSentry is available primarily as a SAST deployment for ease of implementation, but also can be delivered as an on-premise installation. For example, if you have an air-gapped network or other specific requirements around binary analysis. So just like we showed DevSecOps for source, DevSecOps for binaries, we're going to bring it into the test phase. So organizations have been doing binary analysis as a QA activity, but when you run it in that way, you run the risk of discovering vulnerabilities too late to do anything about them. So we want to integrate the CodeSentry binary analysis right into that DevOps workflow every. So this is your basic workflow. Is on each merge request, you're going to compile your source code, you're going to link in your binaries, you're going to run unit tests and functional tests, you're going to run your static code analysis on your source code, and then you're going to end up with some form of binary software package. And a lot of organizations might do some further testing, installation testing, or deployment testing, but really that binary software package, if you think about it, is your release candidate. If you were going to release tomorrow, that's the software you're going to release. So what we're going to do is take that binary that's built as part of your merge request, and we're going to submit it for analysis to CodeSentry. We're going to get back security scores and key performance indicators from the tool that will allow us to pass or fail this particular build or merge request. And then out of those findings, we can create tasks for developers so they can investigate them and decide how they're going to remediate these vulnerabilities that have been found. So if we take a look at the workflow here diagram, you'll see on the right our source code and our open source components and our third-party binaries into that software development lifecycle. And then as we go into the test phase, what we're going to do is push our binary artifacts to CodeSentry via the CodeSentry API, and then we'll retrieve our software composition analysis findings from CodeSentry also via the API, and then we'll review those results and pass or fail the build. So those findings coming back, for example, we can use those to automatically pass or fail the build, or we can decide, we'll pass the build every time, but we'll have a separate offline meeting where we'll review the results and decide, do we need to upgrade some open source packages or content? What kind of zero-day and end-day vulnerabilities we found. So this is an example output from the CodeSentry tool. So on the left, you've got the bill of materials. So what you have is a list of every open source software component that's being discovered inside your binaries, along with the component version that was identified. Based on that information, CodeSentry can deliver the list of CVEs or end-day vulnerabilities that have been reported against that software. And they're also reporting which file in your package that software was found in. So you can actually decide, for example, if you're packaging up a number of executables, you might just remove one executable from that package and remove a security vulnerability with it. So it really gives you like an X-ray into each of your binary files of all sorts, executable link libraries, device drivers, all that kind of code. And it looks in there and it tells you what software components have been embedded inside there. Then if we look in the center of the screen here, this is an example where we've detected in a file called myfile.exe, we've detected OpenSSL 1.1.1i, and you can see here in the CVE distribution, it has 4 high vulnerabilities that have been reported. So this is an existing piece of software that's shipping, and it is using a version of OpenSSL that has some serious security vulnerabilities in it. All right. So now we know we need to find out if we should upgrade this version of OpenSSL, or maybe this is buried in a component from a third-party vendor. So we're going to tell that third-party vendor, you've got a vulnerable version of OpenSSL and you need to fix it. Now, the information CodeSentry presents from your detected components, like I mentioned, it's component name and version information, the vulnerability information, so CVSS score and CVEs, but also CodeSentry is going to reveal what functions from that library or component are actually used in your code. And this is very important because you could be using a vulnerable version of OpenSSL, but maybe the function that's vulnerable in OpenSSL does not get called in your code. And obviously, if you're looking at source code, you know this, you can look at this directly. But if you're looking at binaries, you don't actually know what's happening inside that binary. So we're going to be able to tell you with CodeSentry what functions from the library are being used, and then you can use that information to determine if in fact you have a vulnerability or not. So once you've got your product ready to ship, in a lot of industry verticals such as medical, you've got to prove that you've got a process that provides security compliance for your product. So the CodeSentry tool will provide a downloadable PDF report. It has a summary of the security of your product. So for example, it's got a security score, 100, and then it breaks it down into end-day and zero-day vulnerabilities, and also a scan quality so you can make sure that the actual scan had a good result from the files that were inputted. And then it also provides a detail on all of the vulnerabilities that were found, in which files they were found, and what distribution of vulnerabilities you have. So the key takeaways here in DevSecOps for binaries is that open source and third-party binaries can contain end-day vulnerabilities, which are very vulnerable to exploitation. Binary software composition analysis can detect vulnerable components throughout your development cycle, so you don't have to wait until the end. And this early detection of vulnerabilities, for example, gives developers extra time to update their OSS components, or contact the vendor and gives the vendor time to update their third-party component they're supplying to you. It reduces the risk of releasing software with known exploits. So this is, a very, very serious problem. We've seen a number of issues in the news over the last couple of months, and this issue will continue simply because of the challenge that software development organizations have in identifying vulnerable components. And with software composition analysis using CodeSentry, you can get that done. So to conclude, security must be built into the development cycle, not just left to the quality assurance people before release. This is how we're going to get a speedy software development with a high level of security and a high level of quality. Early detection reduces the cost of remediation and the risk of missed release dates. And static code analysis and binary software composition analysis can help you achieve this goal. All right, so that concludes my talk. Again, thanks for joining us here today. If you have questions, I'll be hosting a Q&A session in the sessions area of the conference app. So thanks very much, and I hope to see you in the Q&A.